Hey everybody, welcome back. It's Mr. Bennett, and we are in a new section looking at structure of atoms and the structure of the periodic table, how they go together. So we're going to start off with the models of the atom. We cannot see atoms, so we have to use models. And models are guesses, and they're not just random guesses. It's an informed guess. So we have a lot of data, a lot of observations about atoms, so we can kind of figure out what shape they have, what physical space they take up based on those observations. And it starts off with a guy named John Dalton. And he used the hard sphere model, and he said that atoms are indivisible. You can't break them up anymore. So really, it was mimicking and building on what the Greeks had said about atoms, is that you eventually get a thing you can't cut anymore. Atomos was the word. And so he just said atoms are this hard thing. It's a sphere, so it's kind of roundish, right? It's all the same all the way through. It's just like a hard ball. Think of a marble would be the best example. And that these are indivisible from one another. There's 100 years after that, a guy named J.J. Thomson was playing around with matter, and we'd kind of worked under this assumption that atoms were, essentially just stuff. And Thomson, what he found out is that atoms have positives and negative particles using what's called a cathode ray. And a cathode ray is like a beam of electrons that interacts with a magnetic field. And I've got a video linked in my playlist that you can go look at if you want to see what a cathode ray looks like. But we had to change the model. It's no longer just a hard sphere. He used what he called plum pudding as an example. And plum pudding is kind of like a chocolate chip cookie. So here's our atom, and it's got some positive particles and it's got some negative particles all kind of mixed in around. You can't tell where one or the other is. They're all just there, and they're existing, and they're happy together, and so on and so on. And he actually calculated the mass of the negative particle, definitively showing that an atom is not just a hard sphere, that there's made up of smaller things. So really, he described the electron in a much more significant way. Fast forward another 6 years or 7 years, and we get this guy named Rutherford. And he did an experiment where he shot positive particles toward some gold foil. And remember, he's working under this model that an atom is kind of a mixture of positives and negatives. So if you shoot a positive particle think of like a wall of atoms, right? So he had this wall of atoms lined up, and he was shooting a positive particle at it. He expected those positives, let me change my color. He expected that positive to come and bounce itself off of there. What he saw, though, was that these particles went straight through. And that was really huge. No one expected that. It was a very, very significant discovery. And it changed what we thought about the atom. It's no longer this hard sphere of mixed up positives and negatives. Now it's a hard positive nucleus with these little negative electrons around the outside, and they kind of zip around. So this is like the structure of the atom we're used to seeing in like textbook stuff, right? So they're flying around the outside, kind of this shape. And he called this the planetary model. So it said that most of the atom was empty space. A couple years after that, another guy named Niels Bohr, he noticed that atoms gave off very specific colors when they were energized, very specific wavelengths. And so what we call the Bohr Model, he said that the nucleus sat in the middle of the atom, that it's positively charged, and that electrons stayed around the outside of the atom in definitive orbits, kind of like the planets in the solar system. And it kind of works because we do see these properties. And again, our model had to change. Whereas Rutherford said they go around the outside, they're just there. Bohr said, nope, they go here, and they're specific energy levels. And so then about 13 years after that, we have the quantum model. And this model is crazy. We're not going to get into this much at all. But essentially, the quantum model says that protons, neutrons, electrons are made up of even smaller particles. But we cannot definitively say the electrons go in this specific orbit around the nucleus. We know the electrons are around the nucleus, but it's only a probability. So this is probability based. So they took the Bohr model and they're refuting it by saying, I cannot observe that specific arrangement of electrons, so we cannot say this is a working model. And this is the accepted model of the atom now, the quantum atomic model. And so here's a diagram of what we think the electron shapes kind of look like. We call them the electron cloud. And it's a probability model. So most of the time they're in these kind of shaded areas. So over time our models have to change. And this is how science works. And day to day we use different models to figure out how the world works around us. So there's some critical thinking questions at the bottom you can use. If you want to get a copy of the handout, remember you can always grab that from the website. Take a look at the rest of the videos in the playlist. They'll help you kind of get over the models and the structure and a lot more information regarding atoms. So thanks for watching. I'll see you in class.